you all for coming back. We've got a caching talk this month. I just want to touch on a few things to make sure that you are aware of them. We've got stickers, we've got a t-shirt to give away, and we have JetBrains, whatever you want, license to give away at the end as well. The stickers will not be raffled away, so just please come grab stickers and so that I don't have to go home with them. If you're interested in speaking, we're always looking for more speakers. If you're interested in speaking at conferences here, if you go to papercall.io/events, keywords, and you can click on that you filter by PHP, and here's some upcoming conferences that are accepting papers. So for you to consider.
So it also has a list of conferences that are calling for papers as well.
Okay, yep. For those of you who don't know, we've got Slack, AustinTechVideos chat.com. You can click on a link there at the top and join. Let us know if that doesn't work. We're crossing our fingers and hopefully that will continue to work. So,
worked twice today.
Okay, good. What else is up here? PHP Weekly.
I like that. I subscribe to that. It's actually really interesting.
Okay. So PHP Weekly, if you're at email news, check that out. And they've got Twitter there as well. And then what's Key Scene, like ATX tech events?
Is
Yeah.
PHP Weekly how you hear about like dog equals being depreciated?
No, that was just somebody on Twitter.
Twitter, yeah, the PHP maintainers on Twitter.
That was somebody random on Twitter
Ranting.
throwing a something out there and somebody PRing it.
Did that happen?
Yeah, so ATX tech events, if you want to follow them on Twitter, they kind of have a good list of things that are going on in Austin for you to be aware of. And then there's some info, there's some other info here on how to, well, if you're signed in, there's an about thing. I don't know if it works.
You're looking at it right now.
Oh. Oh yeah, okay. Click on the about. If you actually click on that link, there's some useful info there. If you're looking for a job or looking to hire, the Facebook group here, I think you have to be signed in, but it's Austin Digital Jobs on Facebook. So that's where we're sending everybody to, so keep an eye on that. If you fit into either of those buckets, that is the place to go.
Except if you want to buy the entire meetup here, in which case you should sponsor the beverage subgroup.
Yes. Yes. We also have an resume email BCC list as part of the group and helps support the group. So if you're interested in sponsoring, get in touch with myself or Ian, mainly Ian, and we can get you guys set up for sponsoring the beverage subgroup. I believe
the last Wednesday of this month.
it's usually the last Wednesday of every month. So
to confirm and make sure that we can have it over at Full Circle, because
now Junior Man's closed.
Yep. Junior Man's not going to be open for like another year and a half when they move over to Plaza Saucia.
I think maybe we should have it a couple times at the PHP Pizza.
Pie House Pizza.
Yeah, Pie House Pizza.
Well,
I like that one.
House pizza.
Then you have to find a sponsor who's willing to pay for pizza.
Yeah. So those are your options if you're interested in sponsoring. It definitely helps out the group, and we appreciate it. So thank you all for coming. Stick around, and we'll raffle away the stuff at the end. A speaker this month, Matthew, we're not going to switch. He's going to give the talk from this machine. So just give me a few minutes to go up to the camera, and then we'll get started. Yeah, let's go ahead and get started.
Coming. Today I'm going to be talking about, in this case, the e-commerce application I'm using here is CS Cart, but this should apply to any e-commerce, complex e-commerce solution that you're using, or any complex application that you've got running in PHP sitting behind a framework of some kind. All right, so I mean, underlying this all, the reason why it's CS Cart is what I'm using. None of what I'm saying, by the way, is meant to be a political statement. This isn't, I'm not suggesting that CS Cart is the best cart in the world. I'm not suggesting that when I say Redis is the best caching solution in the world. It's what I use in this case. Any shopping cart or caching solution should work in a similar kind of scenario. But in particular with CS Cart, it is reasonably performant. The code base is not open source, but the code is none of it's encrypted, so you can change any of the code in the underlying engine itself. And most importantly, I think for this particular talk, is that its design is fairly representative of most of your PHP applications these days. It's got a templating engine. It's Smarty 3. Again, this isn't meant to be a political statement of any kind. Any templating engine here would apply in a similar kind of fashion. It's got caching built into it. Memcache, Redis are some of the, it's got a file cache as well. You can basically pick your preferred caching engine that it supports. It's got its own framework. It's not any of your standard frameworks. And like most complex e-commerce applications, it's pretty database heavy. In this case, so this is an e-commerce solution. It's doing pretty heavy traffic, several hundred orders a day coming in through the website. We're not dealing with a multi-server load balancing type scenario. This is all running on a single dedicated machine. What makes this particular situation unique is that in most cases where you're caching, you can cache for some specified period of time. Maybe you can recache every hour, maybe you can recache every day. In this case, the inventory that they're carrying is typically like out of stock kind of things. They get a big shipment of a company that's getting rid of all their stock, or maybe going out of business. They've got a lot of quantity one items, meaning that once it's sold, that product shouldn't be showing up on the website anymore. It's not just an issue that you've got, you've got now 11 in stock versus 12. It's 0 versus 1. And in this particular situation, that's a big deal because if you're off by 1, now you've got pissed off customers. They've got tens of thousands of products. So if you were caching this, if you were having to cache each page on a regular basis, you'd be talking really about caching tens of thousands of pages at whatever kind of interval you want to do the caching. And because of these frequent sales, this is more than just like a theoretical problem. They really do, these pages really do need to be updated on a pretty regular basis. In this case, we're doing it every minute. All right. So just some basic processes for kind of optimizing whatever application that you're running, be it e-commerce or whatnot. We went through the process of identifying scripts that were running for a long time with this shopping cart, identifying non-optimal queries, optimizing the way that the database works, its memory usage on the server that it was running on. And then the other thing that's really hard to do just in your own development, on your own development machines versus in production, is knowing what queries are going to actually be taking the longest time to run, especially in an e-commerce scenario where people are doing searches that you never really kind of expected them to be doing. People are spending more time in particular areas of your site than you expected. And really what can end up happening is that database queries that you've already kind of planned for, that you've designed for, may not actually be the problem with your shopping cart. So I set up a cron script that ran on every few seconds actually, that checks a process list for MySQL, and then alerted me, once I saw a process taking more than 15, 20 seconds to run. And at this point, I've still actually got this running. So if I see a query sitting in the queue that's taking more than a few minutes to run, it just proactively kills that so that your whole shopping cart doesn't come to a crawl based on some unfortunate query that someone has entered on your website. So doing all that, and if that solves your problems, that's probably good enough. In this case, it wasn't good enough. This is an e-commerce site. With every round of optimizations that we did, every time the website ran faster, the sales increased. So there's definitely a correlation between how fast the site runs and how well the sales are doing. So moving on, caching is one of those situations where when it works, it can work really well. When it doesn't work, in this case with a pretty complex application, it doesn't work at all. Really in this e-commerce kind of scenario, if it doesn't work 100%, it might as well not be working any portion of the time. All right. So if we're going to look at a static caching solution, what you might naively assume, we'll cache every page in the site. You'd really be talking about caching hundreds of thousands of pages, and if you're having to do it in this case, we're doing it every minute, but even if you're doing it every 15 minutes, just the caching process by itself gets to be overwhelming. The other issue with e-commerce specifically is that because this is session-based, you really are serving queries that might change from visitor to visitor. Static caching really is just not an option at all here. Okay. If you're working with framework, chances are that framework has its own built-in caching solution, which you are certainly welcome to use, and I would assume probably even if you're not intentionally using it, it may already be switched on. The issue with this is typically with some of these really big frameworks is that just by using their caching solution, you're already loading a ton of code associated with your application. You could certainly look at something like Varnish, and in this case, there's a Varnish plugin for CSCart. The issue with that is that it really only works if no session is set, if no products are in the shopping cart, which effectively means that unless you're Google, it really doesn't help you out at all. So, it's useful for speeding up Google's ability to spy to your website, but the minute you've got a real human being on your website adding a product to the shopping cart where the quantity suddenly jumps to 1, off-the-shelf solutions fail. And then in this case, since the shopping cart itself already supported Redis, Memcache, a few other solutions, those caching options were already there. We didn't have to add an additional potential point of failure. So in terms of thinking of this problem, I kind of took a step back. And it's really easy when you're looking at a big, fancy framework to think within the context of that framework and not really considering, what's going on under the hood. But in general, what this shopping cart, what any PHP application is doing, is loading a PHP engine. It's initiating and restoring a session. There's a black box, which is your framework or whatever. It's where all the magic happens. And then there's some output that is rendered to the web browser. So one of the first things I looked at doing here was just taking that output, caching it, and spitting it back out to the user. The idea being you hit the, red widget page, and you get the same red widget page that everyone else has seen. In order to do that, what we did was take a look to see where the last bit of code is running in the framework itself in this case. And every time that I mention, except for this very first example, you can assume that it's all code that sits inside this function, dispatch function. We store the output buffer, cache, and render. Pretty standard kind of stuff. In this case, we're using Redis. I did use for this particular project memcache for a while, and then it was memcached, I guess, and moving to PHP 7 maybe. The issue that I had with memcache and memcached in particular is that once the cart had been running for a certain period of time, or once it had consumed a certain amount of memory, memcached crashed on me. Had to manually reset memcached, didn't work. Obviously, in an e-commerce situation where you've got to constantly restart your caching solution when it clears itself out, it's not doing a good job. So Redis here seemed to work fine. I haven't had any problems with it. Maybe Logan, I don't know if you have or not. Okay. The advantage here, right now I mentioned that we don't have multiple like load balancers and stuff. If we did, the advantage of using Redis is that we could start to take advantage of that feature of Redis. But right here at the very beginning of your code, I guess it's not going to work. We're basically initializing our Redis caching engine and then checking to see whether or not we've got this in our page cache. One of the important things here where I'm checking to see if we've already started the output buffer, you definitely want to do that. The last thing you want to do is flush the output buffer or start output buffering when it's already started up. So this OB get level, if it's greater than 0, it's not restarting the output buffer on you. All right, next step, going to this function dispatch deal. We're grabbing the global Redis variable that's in place. Taking page content is just grabbing the contents from the output buffer. We're generating a unique key based on the URL that the user is looking at, and then associating that page content with that particular key, cleaning up our engine, and spitting out the page output that we've got cached. Go ahead.
So if you're using just the plain old URL as the cache key, how are you differentiating between user sessions there? Because that seems to give you the same problem that you would have had.
Sure, absolutely. Yep, and we're going to get to that here just in a minute. Okay. And just to give some context here, basically I'm starting with a naive approach, and then we're going to look at where it fails and how to fix some of those failure points. All right. Displaying the cached output is fairly straightforward here. If the page is cached, it just spits that out to the screen. What works? Obviously, the content gets cached, and the cached content is displayed. Things that fail, CSCart has a security token that is, per user, per session kind of deal. We're caching that security token here, which obviously doesn't work. In this case, the shopping cart tells you that there's a potential attack that's undergoing on your site currently. Shopping cart totals don't work. You add something to the cart, well, it doesn't ever change from whatever the cached total is in your shopping cart. User actions stop working, things like add to cart, which is obviously an essential function with a shopping cart. And then getting back to the core challenge that we're trying to solve here is that your inventory obviously is not getting refreshed. In terms of fixing the security token, it's really not that difficult. It came down to tracking down the function responsible for setting up or initiating that security hash if it's not already there. So for example, if a new user comes to your website, obviously there's not going to be a security token set for that user. So in that case, we're preemptively calling this function to generate a hash for that user. The next block of code here looks through our cached version of the page to identify what security token has actually been hashed, and then it goes ahead and replaces that cached token with the per user session-based token that we've just generated.
So does that then change the actual cache? You go in and change the cache with the updated security token?
If we have, so in this event, we are setting, so if we don't have a security hash set in the session, we'll go ahead and set that for the user. Does that answer the question?
Well, but it's the next one down that you're finding the token. Are you finding it in the cache?
Yeah, so here, so on the page, wherever I've got the session hash set in the JavaScript code, it's on page JavaScript code, it's preceded by security hash equals. So that's the string that I'm looking for to identify where in the cache that token is sitting, and then it's just swapping that out. Exactly.
That is after you pull the page content from the cache before you display it.
Correct, yes. All right, next item, making sure that the totals in the cart actually show correctly. In this case, CS cart sets the products inside the session itself. So I can just look and see from the user session how many products they've got in there. In this first if statement here, this is in the case where you've got one product but multiple quantities of that product. Otherwise, it assumes there's one of that product. And then just the same way that it searched through the cached code on the page for the session for the session prefix, here it's searching for the HTML code that stores the cart total and then swapping that out dynamically as well. All right, so Ian, to your question here. Whenever you got a problem, you can try to solve 100% of it. It can get extremely complex in the event where you want to solve 100% of it. By going through this process, what we did was identify how we could solve 80% of the caching issues here. In the case where the customer adds a product to the shopping cart, in the case where a user has logged into the shopping cart, in the case where an administrator is going in acting as a customer, these are all situations where you can't, and anything is possible. It's possible that if the customer is logged in, they might have some special discount pricing that only they receive, in which case there's no benefit to caching associated with that if that specific user only sees that particular price on their screen. So in this case, we're caching the home page, we're caching every product page, we're caching every category page. For a shopping cart, that's 99% of the traffic to your website. There's going to be some segment of users who log in to make their purchases. The site runs a little bit slower for them. There's going to be some cases where the store owners go in and make a purchase on behalf of the customer or see what problem a customer is looking at. The site's going to run a little bit slower for them. But in the case where you're not logged in, where you're looking at the home page or product page, category page, you're seeing extremely fast load time for this process. The big challenge here in terms of keeping inventory fresh is really where I'm going to spend most of the time. Because I think that out of anything that we did here, this is kind of the most unique aspect. So we discussed about the product quantity changing on a regular basis. Our objective here was to be able to change or keep product quantity up to the minute basis. The general assumption being here that a customer is not going to add a product to their shopping cart and complete the checkout process all within a minute. So the shopping cart itself does a final check before the sale is actually processed to make sure that they've got adequate inventory. So if your cache is up to 60 seconds out of date, it's generally not a problem. The other big issue here is that, just a second, is that once your inventory hits 0 for a particular product, that corresponding category page has to update as well. So in this case, I believe we're showing 24 products per page. You can't just, I mean, it looks awkward if suddenly you're showing 23 or 22 products on the page. So in this case, we want to make sure that a product quantity change updates a corresponding category page. Yes?
How did you arrive at the 60-second kind of thing?
It's not especially technical. Cron runs every 60 seconds. We've just got the cron script running every minute. That's it. Any other questions? Okay. The only thing that kind of was unexpected from this whole process is that in order to make this work, it really became necessary to go into the underlying template that defined the product details itself. So this is what Smarty, in this case, is rendering. Whatever templating engine you use, you can go into the corresponding template and update it accordingly. But what we're doing here that I think is kind of unique is that we're embedding a comment on the page. And what that comment amounts to is AMT is just a prefix. This is arbitrary. It could be whatever you want it to be. Dash product ID followed by the amount. That's the amount that we have in inventory. And what this is going to allow us to do is to really quickly determine if we need to refresh that cached page. The cron script itself is just going in and grabbing the inventory amounts and storing this to cache. This lets us really quickly do a swap on the page itself. We're going to get to here in just a minute. All right. So at this point, we've got our template, which now has an embedded tag on the page that is essentially telling our custom code here, the last time I cached this page, this is what I saw for the inventory. So we're grabbing this cached inventory information from the Redis cache, and keep in mind that while this is being cached, it's being cached on a per minute basis. We're using this string, I believe it's token replace, maybe is what that abbreviation is for. And we're just dynamically swapping all of those tokens that we've stored with any tokens that we've got on the page. Then it's looking to see whether all of the tokens with this particular prefix, whether there's anything left on the page. Okay, this is a HTML comment. The user, the visitor to your website never sees this, and in fact, once this is rendered, no one sees it anyway. But if it does find that particular tag on the page, what that means is that the cache is out of date. So it tells our code to go in and recache the page, which is what's happening down here. Before we started doing this project, CSCart, so there's CSCart, the way that it runs if you got it on its own machine. There's CSCart, the way it runs when you've actually got it in production. Prior to making any changes here, it was easily taking over 1,000 milliseconds, 2, 3 seconds, 4 seconds sometimes, to actually render these pages. A lot of this has to do with the database calls themselves. There's a lot of things going on. After making these changes, the execution time for these scripts dropped substantially. I compared the page load times on these versus like a really basic PHP script without database access at all, just almost essentially doing a hello world kind of thing. And this ran only slightly slower than your basic non-database driven PHP script. In the case where you've got to recache, it takes a few hundred milliseconds to run. The only explanation I've got right now for that is that we're hitting the database less. So the database doesn't have such a heavy ongoing load that it has to chew through. And then there's the aspect of what the end user to your website sees. And in this case, it went from, during peak traffic, the site was slowing down. They would run these email campaigns, email blasts, 70, 80,000 people would all get this email saying, we're running a deal on these closeout fabrics in this case, and the site would get hammered. And at peak times, it might take 7, maybe 10 seconds for a page to load. Obviously, that's a problem when people want to buy from your website. So reducing the server load is a big component there as well. So in addition to the overall experience being much more pleasant, it's a much more consistent experience. So at the peak, you're still getting a similar experience to when the site's at its lowest. In retrospect, it's easy to say, well, why didn't you do this, or why didn't you do that? And so I want to run through a few of the things that I either considered or actually tried, and it turned out to be slower. One of those would be caching the product pricing. The issue with that, in addition to it being another set of data that you have to cache, the way that CS Cart works, the way that a lot of shopping carts work, it's a fairly sophisticated process that they've got for determining what the price is that's going to be shown to the customer. So, for example, you typically have your base price. And then if you've got a category level discount or a potential coupon code that's being applied, or there's all kinds of different scenarios here, that makes it really difficult to cache an accurate price. But really, fortunately, in this case, it turned out that the inventory was changing more frequently than the product prices were changing. The nice thing here is that while inventory changes are driven based on customer behavior, so these are random, they're happening all the time, you don't know when you're going to hit a peak or a lull, so there's no way that you can predict, for example, when you would recache. In the case where you're changing prices, that's an administrative kind of action. So if you do make a price change, a substantial price change across like a broad swath of products across an entire category, you can clear out that cache as an administrative task. So the pricing itself turned out not to be a real big problem. But in your case, there may be other factors in addition to, let's say, inventory. You could cache it just the same way that we're caching inventory in whatever your situation is. Your pricing, maybe you've got a better handle on it than I did. It's a fairly complex shopping cart. There's a lot of code behind how prices are calculated. I didn't really have the time or inclination to figure it out. In your own situation, it may not be such a big challenge, or it might be a higher priority. The other way that you might look at approaching this is to say, well, why don't you just show, you're already caching what amount you have in inventory. Why don't you just display that directly to the page itself, right? Instead of having to invalidate the cache and recache every time an inventory changes, why don't you just display that directly from the cache itself? And I took that approach. What ends up happening is that when you have to do these tests to see, did my inventory change? It did change. Okay, now let me replace it with whatever is currently the cached inventory amount. Ends up being slower for the bulk of the cases where you don't have to recache. So while a cache miss may run slightly faster, your cache hits run substantially slower. So it ends up, you end up giving up more than you actually gain if you decide to display inventory from the cache versus just using the cache to invalidate what you've got. And I already mentioned as far as memcached versus Redis, maybe you've got better experience than I do with memcached, but it turned out to be a more stable option. When you start doing this, you can start to take advantage of some additional tricks. And in this case, I put up just some example representative code. If you've looked at optimizing page load times, there's like some magic things you can do. In this case, prefetching. There's like pre-DNS lookups. I'm not sure everything that's going on here. Pre-connects. When you've got all of your content that's being displayed to the user being cached, you don't have to go into the underlying shopping cart itself, into the engine, and try to figure out where it's updating meta tags or go and figure out which templates are being compiled to create the output. You can actually, at the time that your content is being rendered, go ahead and swap in whatever additional code you want to run on the page. So this turns out to be really neat as well. Does that make sense? So at this point, I think that probably went a lot faster than I was expecting it would. Does anyone have any questions? Go ahead.
So, this is pretty cool in terms of optimization, but it seems like there's a degree of, one of the things I'm sort of wondering about, and this is kind of a dumb thing to wonder about, is like there's a bunch of different shopping cart PHP things written already. Surely there must be a shopping cart that already has like caching working or whatever. Is it just like more expensive or like?
Sure. So,
Like what other shopping products?
yeah.
There's some that
Sure.
have, like caching.
You know, I mean, I've been doing this a while. PHP e-commerce solutions with what's out there on the market, both closed source, open source, free for pay. Unfortunately, the number of shopping cart options that you can host yourself that you pay for has kind of almost disappeared. Most of these for pay solutions have moved to kind of a SaaS model. So what you're talking about generally is looking, I'm sorry? Generally, you're looking at open source offerings. There's kind of hybrid offerings. I mean, Magento is in my opinion, kind of one of those hybrid offerings where really they want you to pay for it, but there's an open source code you can use.
Have any of the open source ones implemented like caching basically?
Yeah, so let me be clear here. CS Cart has its own built-in caching, and Press to Shop supports caching. Most applications these days, at some level, have caching. Okay, you can cache the templates that you're rendering. You can cache certain database lookups. I mean, probably your database has its.
Kind of dynamic caching. Like I don't think it's like, I don't think you invented it. It's great to give a talk on, but I don't think it was like invented this year.
No, and I'm not claiming that this is you know whatever the.
Shouldn't it have made its way into like an open source shopping cart, or like I'd be kind of surprised if it hadn't, I guess, because especially considering like the dramatic results, I guess.
Well, what you have to keep in mind, and it's really easy. Every open source shopping cart out there claims to be the best. You know, the most secure code, runs the fastest, the most user-friendly. At the end of the day, it's one thing to be selling things online. It's a different thing to be doing serious business, relying on this to pay people's wages, to be doing millions of dollars a year through your e-commerce site, okay? So there are a ton of e-commerce solutions out there, old, new, open source, closed source. in terms of, you know, have any particular ones do any particular ones have a perfect caching solution? Maybe. What happens, though, in these cases where you've got a particular use case that is not something that everyone is tasked with? How many merchants is it mission critical that their inventory be updated on a per minute basis? Very few. I mean, most people who do quote unquote e-commerce, you know, aren't doing more than maybe a handful of sales a day, right? So, you know, the load that their shopping cart is putting on their server, for example, is fairly typical. There's really no reason for them to optimize beyond what their particular shopping cart has already optimized for. What we're talking about is taking a situation where, you know, you've flipped on all the switches that your application gives you to flip on, or your framework gives you to flip on, and it's just not still fast enough.
Okay. So I have a different question that's more technical. You can go first.
So you mentioned that you have a cron job that looks for your long-running queries, and if I recall, you just kill them.
For the really long ones, yes.
Okay. Has there been any kind of profiling that you did to see where specifically your bottlenecks are? Like, I mean, there's a bunch of tools like New Relic and Blackfire and those kinds of things like that could tell you exactly, you know, pinpoint this DB query is always going to take you 800 milliseconds. I'm sorry. So you may want to look at it. Did you like run through all that?
Sure. So I've looked at some commercial and open source offerings. I mean, there's built-in code profiling or query profiling within MySQL itself. So I did look at some of those solutions, and really what it comes down to here in this particular case, you're profiling a production server, right? It's one thing to take your dev code and simulate, I don't know, 10,000 users hitting a site versus having actual users hitting a site and doing whatever actual users do, which typically is not what you expect. So in this case, that cron job, which actually I think is kind of neat, it really doesn't impose any significant load on the server itself. That process list is there for the taking. You just grab it, and then it's looking to see, do I have any that have run past a certain period of time? The general assumption being, for example, if you've got a 5-minute running database query, no user is sitting around waiting for that to come back to them.
Now, if you had a load balancer in front of it, the load balancer would have long since killed the connection anyway.
Sure.
So, riffing off of Buster's question, did you see in any of those queries stuff that probably the one big thing I've seen with database queries on stuff like this is that if a query is running for a long time, it usually means that there are indexes missing on the database. Did you see any cases of that, and were you able to resolve some of those based on the slow queries that you were seeing?
In theory, sure. I don't think the reality is that we made, the only serious change that we made here is switching it from my ISAM to InnoDB. I mean, that's a substantial change that we made to the underlying database design itself. As far as some tables having keys versus others not having keys, the cart is built fairly well. I mean, we're on version 4 point whatever now, so it's been through quite a few iterations, and they've got customers around the world using this in production as well. So they've done a fairly good job of optimizing database structures. So based on kind of what you were talking about in terms of, surely some shopping cart has done this already. One of the things that we did do that would be like a per customer optimization that you can't go back and if this was open source, contribute the code change upstream. This shopping cart is designed that you could, in like an eBay type scenario, have multiple merchants all selling through the website. What that meant was, with every single database query, it was also joining it against this multiple user table. There was only one user in this table. So all these queries were unnecessarily complicated with this assumption that multiple users were using the same cart. So then that meant that there were permission checks all being done every time a page loaded. There was all these joins being done that were really unnecessary. So you couldn't, in a general sense, say, okay, we're just going to disable this for everyone. For this particular client, we could. Go ahead. Your next question, though.
So one of the things I was wondering is, did you end up caching searches at all? And also, did you like think about sort of using like a search thingy, like what's it called, like Elasticsearch or like yeah, or like Sphinx or whatever?
Yeah, sure. So as far as the search is concerned, I mean, there are a number of challenges with this particular use case. So for example, we looked at the idea of being able to supply the inventory across multiple marketplaces. Because inventory is changing so frequently, you can't. I mean, you might have sold out on Amazon and you're still selling it on your website. Where that applies to search is that, again, the search that you do right now might return a product listing that's not relevant 15 minutes from now. Really what we did as far as optimizing the search, and this is not something that people do, you know, in terms of where they spend most of their time on the website. Maybe they do one search, and then from there they're looking at the results from the products. We did apply an additional optimization that was available off the shelf in terms of improving the way that search runs, and it does cache a specific result set. But again, that has to be updated on a fairly regular basis.
I was just asking about that because what I was assuming is that you have like these really slow queries and like you haven't even solved them to the point where you're still sort of leaning on this query killer thing. And so basically what sort of comes to my mind is like, well, the problem here is that you're trying to do like search like via like a database rather than like a search thing. Like, does that make sense?
Searches were not the bulk of the problem. We did update the search queries so that they ran in a reasonable kind of time frame. We assumed that, you know, if someone writes some crazy query.
Where are these like crazy queries that kill the database coming from then, if not the search?
All over the place. So, you know, so for example, a basic category listing where you're showing those 24 products on the page. You've got to check across multiple tables in order to make sure that you're listing inventory that you still got in stock, prices that are accurate.
That doesn't make sense then, because if it was category listings, then like if it was like listing a category, that would be something that would run into all the time, and like those like the
Sure, and you did.
are going to be like rare queries. They don't happen all the time. So like how are they?
Sure. So.
Surprised at what something like Magento can spit out without you even realizing it's going to happen. A lot of that is because it has to be able to sell anything. There is no database schema, right? The schema is like WordPress, where it's like ID key value. It's an EAB schema to support a lot of this stuff. So you end up with like someone going to create a product that has 72 attributes, and that's a 72 table self-join.
That's right. Yep.
That a customer created and put in the system, so any page that shows that product is now completely valid.
Yep, and to give you a more specific example, when you're looking at an individual product page, the query itself is not that complex, right? You've got a product ID, you're joining a few tables to display the product information. Where it gets more complex is when you're showing 24 different products, and that customer on page 1 doesn't see the product they're looking for. They scroll down. You got to immediately show them 24 new products. They scroll down, 24 new products. Now start adding hundreds of visitors to the page who are all doing the same thing, okay? And suddenly, those category level queries that you're doing start to add up. And then you get the user searching for something really crazy that takes, you know, search may not be the key problem. But the point here is that you are going to get these crazy searches either by someone testing your search function or checking the limits of the cart or whatever. Someone's just done a weird lookup. And so, you've got, let's say, 50 category level queries in the queue, and then you get a query that comes through for a search that backs things up for, 5 minutes, right? And it's just not being dumped out. So, this cron script that runs, that kills these proactively, is designed to do that sort of thing. And for a while, it was notifying me every time we had a call that was exceeding a certain time frame, certain run time kind of deal. And systematically, we address those. So that at this point, it's very rare that it has to actually kill something. And when it does kill something, we're talking about, a process that's been running for 15 seconds, not 5 minutes.
So how much time for questions do we still have, William?
Plenty of time. I got a question actually.
Yeah,
So
go ahead.
does this, I forgot what shopping cart was called.
CS cart.
CS cart. Does it have an API, or is it all just like PHP rendered stuff?
There is an API that you can call. So for example, if you're managing, so if you wanted to build a SaaS product and you want,
Like JSON or something?
sure, right, and it would tell you, how many products are in the shopping cart, or how many are in the catalog itself, how many sales have been done. But the underlying cart itself is not API driven.
Okay. So instead of doing the full page caching and then updating the cache, with things that change very frequently, did you consider changing the things that change very frequently to like JavaScript calls? So like if instead of displaying the quantity on the page when they gotta click a button to see what the quantity is, or instead of displaying how many things are in your shopping cart, click it's just a little cart thing, and then you click the cart to see what's in your cart. So changing some of those calls to be JavaScript and like on event instead of like just here's everything, because then you don't have to cache the entire page.
Okay, so there's potentially two questions there. Let me touch on both. One, the simple question is, you go up to the top. It says you've got 2 items in your shopping cart. The way that this worked before we touched it is you click the little shopping cart button, and down came a menu showing everything that you had in your cart. That was pulled in real time. You certainly could make an AJAX call out of that. And in a perfect world, that's what we would have done. It ended up being much more complicated than was necessary. The customers aren't that tech savvy. They had a problem, with that infinite scroll kind of scenario, right? They preferred the, forward back kind of deal. So it wasn't a big deal that we removed that particular functionality from the cart. If we had the justification, yes. Setting that up as an AJAX call where when you click the cart, it shows you a real time without actually sending you to a cart page, that's certainly doable, and I think that would make sense. Where I don't think it would make sense is you're showing, let's say you're showing 24 products on the page, meaning you've got to do, 24 AJAX lookups? At this point, with the load times that we've got, every single network call is adding substantially to the load time for the site. So the fewer network calls we do, the better load time we get for the page itself. So that's a case of diminishing returns. So in theory, yes, it'd be faster. In reality, once you factor in the network delays, it ends up being slower because the browser typically has like a set limit on how many simultaneous calls can go out. So you don't want 24 network calls suddenly hitting just to show, what products you offer in a particular category.
Another quick question on my side.
Yeah.
What are y'all running this infrastructure on? What PHP MySQL version? Is it running all on a single server, PHP MySQL Redis, or are those split up?
Sure. Right now, it's a single server. It's running whatever the latest and greatest hardware is that we could get. I don't know, a 32-core Intel kind of deal. 128 gigs of RAM. I mean, as beefy a server as we could get, it's always easier to run it on a single server than start to have to talk about like sharding your database and. Go ahead.
Shard the database because first maybe separate the database from the PHP before you
We did. For a while, we actually ran the web server and the database server separately. So, I mean, most of what you think about, we did try. I mean, we really went through lots of different options over the course of years. In terms of separating the database and having it run on its own server from your web server, at the end of the day, it was faster for us to be running it all on one really fast machine than to deal with a network delay between the web server and the database server.
That's pretty mind-blowing to me, because it's definitely kind of contra to like a lot of like the general way that people do that kind of thing.
At this point, so maybe it'll help you understand a little bit better, most of the calls never actually hit the disk. They're all being run in RAM. So, you know, you don't think a network delay is serious. A disk delay, even writing to, you know, in-RAID SSD or NVMe or whatever these things are now, NVMe drives, is still too slow. We're writing this, in most cases, this is coming directly from memory. So network speed is definitely a factor.
But would you like
Yeah.
consider switching to AWS or Azure or something like that in the future?
Sure. So, I mean, I'm familiar, right, with all these different systems. And, you know, the reality is today, there are still hosting companies that do traditional hosting extremely well. You know what all your variables are. You know what their historical network uptime is. You know your security vulnerabilities. I've been doing this a long time. We could certainly try putting on AWS. The question is why? You know, to save what, a few $100 a month? The reality here is, at the point where you're doing serious commerce, a few $100 a month or a few $1,000s a month for server infrastructure is irrelevant if it means that I've got techs who can solve a problem when there's a problem that needs to be solved. And, you know, I'm sure that at some premium price point with Amazon, you can have that same kind of support. But this underlying system itself is a much more complex system. When there's a failure with Amazon, you don't necessarily know where that failure is. At some point, would we consider Amazon? Sure. Yeah. But at this point, we've got a system that works. And when you're doing business, when you're actually making money, if it works, if it's not broken, don't fix it.
That's true. But I mean, the concern is with having everything all on server, of course, is that eventually eventually like the server's not big enough, like for a certain degree of scalability, and like you haven't reached that point yet, and maybe like you can calculate that point isn't in the future, and of course, like caching, for instance, like the gains you get are going to be like many orders of like magnitude, like. But it's like it's a much better idea. It's much more worth the time than like figuring out how to shard things for now. But like I bet there is a point where one server's not big enough.
Sure. And so one of the things that I didn't mention here, we've actually got Encapsula sitting in front of the server. So a lot of our requests for static content on the website, images, for example, is being served by effectively a CDN. It's got some security functionality as well. It's essentially a Cloudflare competitor. I've used Cloudflare as well. I don't know if they still have problems. When they did, the problem that I've got with Cloudflare, I'm sure that you know if you've been to a Cloudflare-based site, because Cloudflare presented you with some kind of CAPTCHA challenge, or they said, sorry, this site's down, or I guess maybe Cloudflare confuses me as a robot more frequently than the average person. But you know, if your customer is coming through a proxy, for example, if they're coming through Tor or whatever, in this case, you're a merchant. This particular merchant, the number of fraud cases of people buying fabric fraudulently is pretty low. I think the last time I asked him, he said, you know, they have one case of fraud a year. You know, so if fraud is a big problem for you, maybe Cloudflare is a better solution. From my perspective, Encapsula seems to provide a better security framework for what we're doing and causes less problems in terms of, you know, the CDN coming in front and challenging you before it'll show you content. So to answer your question, yes, at some point we are going to have to potentially scale up, but at the same time, processor speed is going up. Yeah, everything is increasing at the same time. The question is, which is going to happen faster? Do we reach the point where we've got to, whatever, shard the database, put load balancers in place? Yeah, it could happen at some point. We could say today, look, instead of having one really expensive, big, powerful server, let's split it up. You know, I've got friends like at cPanel who have gone through this process before, you know, fairly complex kinds of scenarios. And, you know, the guys doing it will say, have said to me, if you can just serve it off one server, keep it on a server.
Yeah, because it does cost a lot of money. I mean, mainly like personnel money, because like it just takes a lot of like people time to accomplish that. Generally, yeah.
I have one other question.
Yeah.
You mentioned that you're on PHP 7.
We are, yeah.
Did you see did it help at all?
It did. It did.
Okay.
There was a substantial difference in going from PHP, whatever, 5.4 or 5.6 or wherever it was at last time, to 7. I don't know if we're on 7.1 or still 7.0, but it's 7. And we did see a substantial difference. I don't think that there's as big a performance difference from 7.0 to 7.1, where you see your biggest is 5 to 7. The advantage, and really this is a case where your what you can do is based on what your shopping cart's compatible with. So in moving from CS Cart 3 to 4 is where they made that PHP 5 to 7 transition. So we were able to make that transition as well. It did help. Yeah. But in this case, I suspect in most e-commerce kinds of situations, your database is really your bottleneck. Ian, you had asked what database engine we're using. I have tried MariaDB. I've had a, you know.
Sorry, my question was more version, because like 5.7 is like 10-20% faster than 5.6 of MySQL.
Sure. So what are we at now in MySQL? Maybe 5.8, 5.9, 6?
So it jumped from 5.7 to 8.0.
Sure.
8.0 just got released.
Sure, yeah. So we're not on 8.0. As far as 5.6, 5.7, I would guess probably 5.6. I mean, this is hosted on a cPanel server. cPanel is not typically like cutting edge as far as running the absolute latest MySQL engines. So
it's not like virtual machines or anything like that. It's just one big cPanel instance.
it's running on Cloud Linux. We've got this.
Well, okay, yeah, like the server itself.
The server itself, right. So, I mean, if we need to move this, if we need to migrate this, it is all one big virtual instance. We would migrate this big virtual instance to a new, bigger, dedicated virtual instance. So we're talking.
It's one big VM?
Right.